Inside this machine is enough energy to level a city. A tiny piece of its fuel holds as much energy as tons of coal, and yet it powers millions of homes without exploding. So what stops it from becoming a bomb? The answer is a chain of safety systems so clever, so paranoid, that failure is designed to be almost impossible. This is how a nuclear power plant makes terrifying power and stays safe. It all starts with the atom, specifically splitting one. When a tiny particle hits an atom of uranium, the atom splits in two. This is called fission, and when it splits, it releases something incredible, a burst of heat and more particles. Those particles hit more atoms, which split and release more particles. A chain reaction. Left unchecked, this chain reaction grows out of control, incredibly fast. In a bomb, that is the point. But in a power plant, the entire goal is the opposite. Control it. A power plant does not want an explosion. It wants a slow, steady, controlled release of heat. Forever. And here is something important. The fuel in a power plant simply cannot explode like a bomb. It is not concentrated enough. A reactor can fail in dangerous ways, but a nuclear blast is not one of them. That is a myth worth killing right now. So what does the plant do with all that heat? Something surprisingly simple. It boils water. The intense heat turns water into high-pressure steam. That steam rushes through pipes toward a giant turbine. The steam pushes the turbine blades and spins them at incredible speed. The spinning turbine turns a generator, which creates electricity. And that electricity flows out to power millions of homes. So here is the strange truth. The most advanced power plant on Earth is, at its heart, a very fancy way to boil water. Split atoms, make heat, boil water, spin a turbine, make power. That is the whole idea. But the scale is what makes it special. A single fuel pellet, smaller than your fingertip, holds as much energy as a ton of coal. One reactor can run for over a year before it needs refueling. That is why so little fuel can power an entire city, day and night, without pause. But the real magic is control, and it comes down to something called control rods. These rods are made of special materials that soak up the particles causing the chain reaction. Lower the rods into the core, and they absorb more particles. The reaction slows down. Raise them, and the reaction speeds up. This is the plant's throttle. By carefully adjusting these rods, operators keep the reaction perfectly balanced. Not too fast, not too slow. And modern reactors have another trick. They are designed so that if the core gets too hot, the reaction naturally slows itself down. The physics itself fights against overheating. Safety is built into the very laws the reactor runs on. Just a steady, controlled burn, producing constant heat hour after hour. And if anything ever goes wrong, the rods drop all the way in, instantly. This slams the reaction to a stop. It is called a scram. In seconds, the chain reaction is smothered. This is the plant's emergency brake. And the best part? A scram can trigger completely on its own. If sensors detect anything strange, the system does not wait for a human. It slams the brakes automatically. The plant is built to shut itself down when in doubt. Now, controlling the reaction is only half the job. The other half is containing it. Nuclear plants are built like a fortress, with layer after layer of protection. First, the fuel is sealed inside tough metal tubes. Then, the whole core sits inside a massive steel vessel, many centimeters thick. Around that is a giant dome of thick, reinforced concrete. This is the containment building. It is built so strong that it can survive earthquakes and even a direct crash from an aircraft. Layer after layer after layer. So that even if one fails, the next one holds. Radiation stays trapped inside. The whole point is simple. Keep the dangerous part locked away from the world, no matter what. Engineers call this idea defense in depth. Never trust a single barrier. Never trust a single system. Assume any one part can fail and make sure the next layer catches it. It is paranoia turned into engineering. But you have probably heard a scary word, meltdown. So what is it really? Here is the danger. Even after the chain reaction stops, the fuel stays incredibly hot for a long time, so it must be constantly cooled. Water has to keep flowing over the core without pause. If that cooling ever fails, the fuel can overheat and start to melt. That is a meltdown. This is what went wrong in the worst nuclear accidents in history. The cooling failed. So modern plants have backup after backup, multiple cooling systems, emergency generators, and water supplies. The newest designs can even cool themselves using only gravity and natural flow. No power needed at all. The lesson from past disasters was burned into every new design. Never let the core lose its cooling. And it is worth remembering, in over half a century of nuclear power, across hundreds of reactors, serious accidents can be counted on one hand. Each one taught the world a hard lesson, and every plant built after became safer because of it. So here is what surprises most people. Nuclear power is one of the safest energy sources we have. Per unit of energy, it causes far fewer deaths than coal, oil, or gas. And it produces enormous amounts of power, without burning fuel and without releasing carbon into the air. Unlike wind or solar, it runs day and night in any weather without stopping. A steady, massive, always-on source of clean energy. That combination is incredibly rare and incredibly valuable. All of it held safe by control rods, steel, concrete, and endless backups. A machine that holds the power of a bomb, tamed into a quiet, steady hum. There is one real challenge left. The used fuel stays dangerous for a very long time. So it is sealed in heavy containers and stored with extreme care. It is a serious problem. But it is a small, contained one compared to the invisible pollution that other power sources pour into the sky every single day. From the power in your walls to the systems that keep it safe, our world runs on invisible engineering. And that raises a new question. We tamed the atom, but how do we hold back billions of tons of water with a single wall? How does a dam not collapse? That is coming next on System Logic. Think about that for a moment. We took the most destructive force humanity ever discovered, and we wrapped it in so much clever engineering that it now quietly warms our homes and lights our cities. That is not luck. It is layers of paranoia, science, and steel, all working together in silence. If you learned something new today, subscribe, because the world is full of invisible systems, and we are just getting started.